Hello everyone, and welcome to our video on the CP10 and CP20 display power supplies. Thanks for joining us. I'm going to take you through the main features of these products and show you how they can be used in real-life situations. We'll start with a quick overview of the key features. Then I'll walk you through a live demonstration so you can see the power supplies in action. So let's get started. Before we start operating, please note the following warning instructions. Read the installation manual for detailed warnings. Ensure that the power supply is switched off before installing or deinstalling the device. Mount the device on a DIN rail according to EN 60715. Please use suitable cables. The minimum and maximum diameters can be found in the installation manual or in the data sheet. Check that all furrows are properly inserted into the terminal connections. We start here with a short product overview, including a brief comparison to the regular CP10 and CP20 power supplies. Compared to the high-quality CP10 and CP20 models, the CP20.248 and CP20.248 are high-quality versions equipped with display features, providing real-time and recorded data for monitoring of operation and quick analysis of failures and minimizing downtimes. Despite their identical dimensions and design, they differ in power output. The CP10 offers 240 watts, while the CP20 offers 480 watts. Both units come with several enhanced features such as an alarm contact for overload and temperature warnings, a remote on/off function, and a display showing both live and historical performance data. In addition to these two variants, there is also the CP20.248 IOL model, which features I/O link functionality for seamless integration into industrial networks. This enables advanced diagnostics, digital communication, and remote maintenance. All three models share the same input and output terminals, display framework, and navigation system, ensuring easy operation and smooth integration. Now let's take a closer look at the display, first examining it theoretically before applying the insights in a practical example. When we take a closer look at the device, we can see several key elements. The display shows the different condition parameters on the front for monitoring and easy analysis of errors. Below these are the denomination fields. They show which condition parameter you have selected. On the right side of the display, we find the status indicators, which are particularly important. Alarm lights up when a protection function, such as overcurrent, overvoltage, or overtemperature has been triggered, or if an internal fault has occurred. Off indicates that the output has been switched off via the remote control interface, and DC-OK confirms that the output voltage is present and within the proper range. You can navigate through the display by pressing the display push button. Finally, we have the signal contacts, which provide the functions alarm, DC-OK, on and off, and the single and parallel mode. So how can you select and display the information on the display? With just one button, the so-called display button, you can navigate through the various parameters and display modes. There are two modes available. In real-time data mode, you can see the current condition values of the power supply. In total 5 parameters, the recorded mode continuously records minimum and maximum condition values for analysis and monitoring purposes. Providing a total of 8 values, the display is more than just a screen. It is the central tool for monitoring the current operating status and for reviewing past system data. With just a single button, you can easily switch between different modes. In real-time data mode, the display shows parameters such as input voltage, output current, temperature, and operating hours. The recorded data mode shows the lowest and highest measured values for voltage, current, and temperature. This makes it easier to check your system's condition and analyze possible faults. In this mode, you can review minimum and maximum input voltage, how often the voltage dropped too low or spiked too high, maximum output voltage and current, and lastly, the minimum and maximum internal temperature. Now let's take a look at everything in live operation. On the left side, you'll see the diagram showing all available parameters in both modes. The mode we're currently in is highlighted as we press the display button. This way, you can see exactly which mode we're in and have a helpful guide to navigate through the options. We are currently in the real-time data mode. The first parameter we see is the input RS voltage, here 230 volt. A short press on the display button takes us to the next parameter, the output DC voltage at 24.2 volt. Next up is the output DC current, showing 19.6 amps. Then we have the internal temperature, currently 53 degrees Celsius. After that, the display shows the total operation hours, in this case 0,000 hours. Finally, there's the display that lets us switch from one mode to the other mode. If we now press and hold the display button for 2 seconds, ta-da! We are in the recorded data mode. It works the same way here. A short press of the button lets us cycle through the different readings. First, we see the minimum input voltage at 92 volt AC, the voltage when the system was started. Next, the maximum input voltage, currently 242 volt AC. Then the display shows 3 transient dips, followed by 0 transient overvoltage conditions. After that comes the output voltage maximum at 24.2 volt. Next is the maximum output current delivered since the last reset, which is 19.7 amps. Then the minimum temperature, 21 degrees Celsius, which corresponds roughly to the room temperature at startup. And finally, the maximum temperature reached so far, here 53 degrees Celsius. To go back to real-time mode, press and hold the display button for 2 seconds. And there we are, back at the input RMS value. If we want to see the peak voltage, switch to VN and hold the display button for 6 seconds. The denomination field VN is flashing, and you see the text U peak on the display. There we can see the peak voltage, here 334 volts. To return to the RNS display of VN, simply hold the button for 6 seconds again. And there's the 230 volts from the beginning. To reset the recorded data, go to Recorded Data mode. Press the display button to select the data you wish to reset. Press and hold the button for more than 2 seconds to start the reset process. You will know it is working when the display begins to flash. Keep holding the button until the flashing stops. Once it stops, the value will have been reset to the current reading, which is now 230 volt. Please note that if you release the button too early, before the flashing stops, the reset won't happen. Also, please remember that the minimum and maximum values are always updated and stored until you reset them yourself. And that's it. Now you know exactly how to switch between the different modes. In the next video, we'll look at common input issues in a power supply, voltage dips, transients, and overvoltage conditions. Using a real electronic AC source, we'll create disturbances manually and show how the counter reacts. We'll start with voltage dips and their minimum values, then later cover a maximum voltage transient. Thanks for watching. For more, check out our PULS channel or our website.